Hello, everybody. So we have a quiz coming up, and we're doing things with exponents. And I just wanted to go over it real quick. This first problem really threw people off. Uh, they were not sure what I was asking. And if you just break it down, write a division problem with exponents that simplifies to this. So let's remind ourselves, if we have a division problem with exponents, I'm just making up a random one. What can we do with those exponents? So if I have x to the 5 over x to the 2, what can I do with those exponents? Well, I remember that it becomes x to the 3. And the reason it becomes x to the 3 is because you're doing the top power minus the bottom power. You're canceling out x's that match on the top and bottom. So what we need to do here is come up with a division problem where we go top minus bottom and end up with 0. What I think threw off a lot of you is that there's a lot of different possible answers. X to the third over x to the third works. X to the seventh over x to the seventh works. X to the anything divided by x to the anything works because you do top minus bottom and then you get 0. So this equals x to the 0. But we also learned that anything divided by itself is also equal to 1. So the same answer works for both answers A and B. Anything divided by itself is 1. Anytime the exponents match, you get an exponent of 0. If I use the top minus bottom power pattern one more time, I can just go x to the 5 divided by x to the 15th. Or I could have done x squared divided by x to the 12th. Anything that has a bottom number that's 10 bigger than the top number works to make it x to the negative 10. Okay, next one, we're going to make a table. And we're going to graph it. You can type it in. When I plug in 0, I get 1 times 8. When I multiply by 1.5, I get 12. We multiply by 1.5 again, get 18. We multiply by 1.5 again, we get 27. And this is growth. You should have a graph that's just going up and to the right rapidly. I'm just going to make this value 8. So I'm counting by 4s. I'm going to very quickly it's going to go off of the graph, etc. So we start here at 8, then we go to 12, 18. So this is 1, 2, 3. And then I go to 27. You see it's going to go up like that. Okay, great. Question 3. A computer is worth $600 when it is purchased, and it loses 25%. And that means that if I do 100 minus 25, that every year it keeps 75% of its value. So the amount it's worth in 4 years is just 600 times 0.75 to the fourth power. Which ends up being about $189, 189.84. At any moment in time, I could write a function of time, 600 times 0.75 raised to the t. Very similar process with the number 4 with the bacteria, it's just growing by 12%. So we start with 100 bacteria, and we are growing by 12%. So I have 112% every hour. So for 6 hours, I just replace that with the number 6. 100, 1.12 raised to the 6. Just type it into your calculator. Exactly how I wrote it there. And you should see 197.38. So I would just probably round that down to 197 bacteria. A function that describes the number of bacteria at any time. I should use a different letter because I already used F. So let's use a different letter. Let's just say that the number of bacteria at any time is 100, 1.12 raised to the t. That's it for the first page. Moving on down, we have a graph and a table. And I remember that all I need to know for a graph or a table, all I need to know for an exponential function is what does it start with and what does it multiply by. This one starts with 4. That's the y-intercept. And if I go 12 divided by 4, I get the multiplier of 3. So 4 times 3 to the x is the correct answer for that graph. Similar process for number 6. I see that 64 is the y-intercept. The multiplier is a little bit trickier. I don't expect you to know it off the top of your head. 48 divided by 64 tells me it's a multiplier of 0.75. Or I could use 3/4 if you like the fraction more. I'm going to double check that it works out using 36 divided by 48. Checking that on my calculator, I also get 0.75. It asks me to check that my equation works, so I'm just going to grab a y and x value that I haven't used yet, and I'm going to check. When I make y equal 27, does that really equal 64 times 0.75 to the third? Let's type it in. I'll show you what it looks like on the calculator. See that right there at the bottom? It's checking it. I'm typing in x equals 3, and I'm getting y equals 27. So it really does work. It didn't come out very good on the screen. That's a 3. So that checks out. Great. Let's look at number 7. 3 graphs. And before I even read what the question is, what I want you to notice is that h and g have the same y-intercept, but they are all different steepnesses. H is steeper than g, and g is steeper than f. All right, now we're told that f has this equation, so I know that this is a height of 10, and h has this equation, so I know that this is a height of 20. And I also know that f grows by timing 2, and h grows by multiplying by 4. H is the steepest one, 4 is bigger than 2. F is the least steep, 2 is smaller. So I know g has to be in between 2 and 4. So the only possible answer here is this one right here. It can't be equation C because equation C has a y-intercept of 10. It can't be equation D because that's steeper than H. And it can't be equation A because that is less steep than F. And so they would cross over each other, G and F would. And so that's it. Please let me know if you have any questions or comments, and I'm happy to help out.